Everyone, as I have promised you that a video is going to be uploaded very soon, so I am keeping my promise, and here is the lecture number 5 from the subject basic numericals, that is numericals from the portion KCL, KVL and equivalent resistances. So first come to the first question. Here you can see a resistive circuit is there, and in this resistive circuit you have been asked to find I1 and Vs. And where is the I1? This is the I1, this is the I1 you will have to find, and also the Vs. So first what I am going to do is applying KCL at node 1. Applying KCL at node 1. Node 1 mean here you can see that I have mentioned it at A, that is at node A I am going to find out the current I1 by applying KCL. So in node A you can find that minus 4 ampere of current from here is entering the node. I1 amount of current is leaving the node, and here 1 ampere of current is also leaving the node. So from that I can write that minus 4 ampere plus I1 plus 1 is equal to 0. So you can easily find out that I1 is equal to 3 ampere, which is the first answer of the question. And now the question, in the question it has been asked that what is the value of Vs. So to find out the Vs, what I am going to do is I first find out the Va, and is voltage across here, and VAB, that is what is the voltage in between this, that is the voltage drop across this 1 ohm resistor, and then I can find out the VB, and then finally I will find out the Vs. So first VA is what, 3 into 1, that is 3 volt. Where I can find this 3 is the I1 value, that is 3 ampere, and 3 ampere of current is flowing through 1 ohm resistor here. So from there I can find out that VA is equal to 3 cross 1 is equal to 3 volt. Now what is the value of VB? Here VB is 1 ampere current is flowing through 1 ohm resistor. So voltage drop across this 1 ohm resistor is nothing but the VAB. So VAB is equal to 1 ampere current into 1 ohm of resistor. So it is 1 into 1, that is 1 volt. Now you can find out VB. So what is VB? When you minus this VAB from this VA value, that is voltage and in A node, when you minus this voltage from this, then you can easily find out the VB. Okay, so now VB is equal to VA minus VAB. So VA is here 3 volt and VAB is 1 volt. So 3 minus 1 volt is equal to 2 volt. Now when I know that what is the value of VB, that is what is the value across this resistor, I can easily find out the value of the current I2. Okay, so I2 is what? I2 is equal to 2 by 1. 2 is 2 volt, that is the VB divided by resistance value is 1 ohm. So VB, from VB I can find out I2 equal to 2 by 1 is equal to 2 ampere. Now I will apply KCL at node B. Why I will apply KCL at node B? Because I want to find out this current. If I can find out the value of the current I3, then I can easily find out the voltage drop across this 1 ohm resistor. And if I find out the voltage drop across this 1 ohm resistor, then I can easily find out what is the value of the Vs. How? By subtracting the voltage drop across this 1 ohm resistor from the VB, I can easily find out the Vs. Clear? So here KCL at node B, that is here, you can find out that I3 is leaving the node I2 also leaving the node and I1 is entering the node. So from here I can find out I3 plus I2 minus I1 is equal to 0. So here I can find out I3 is equal to minus I2 plus 1, that is equal to minus I2 minus 2 plus 1 is equal to minus 1 ampere. So now I can find out this Vs. This Vs, here it is Vs. So this Vs is equal to what? This Vs is equal to Vb minus the voltage drop. So here Vs equal to Vb minus voltage drop across 1 ohm resistor, it is I3 into 1. So Vb was previously found out 2 volt minus 1 into I3 is minus 1. So finally you can get 3 volts. So Vs is equal to 3 volt. Okay. So this question is basically for clearing the concept related to KCL, KVLs and voltage divider rule. Okay. Now next question is here. Go on to the next question. What is found out here? For the resistive circuit of figure, find Ix and Vx. Also find R1 and R2. So where is Ix? There it is Ix and this is Vx, and find out R1 and R2. R1 is here, this is R1, and R2 is here, this is R2. Now first see ICD. ICD means this current. I am going to find this current. How? By applying KCL at D, that is at this point. So what you can find out? You can see that 8 ampere of current is entering, 10 ampere current is leaving. So the remaining amount will be the ICD. Okay. So ICD is equal to 10 minus 8, that is equal to 2 ampere. So current is entering here. Now you can find out from the KCL, minus 8 plus 10 minus ICD is equal to 0. From here you can find out that ICD is equal to 2 ampere. Now second is, what is VCD? That is the voltage across this resistor. VCD is equal to 5, that is the ohm, and 2, that is the ICD current value. So VCD equal to 10 volt. Now I just want to find out the Vx. So Vx can be found out by applying KVL here, this is in this loop. So if you apply the KVL in the VCD loop, then you will find VCD, okay, this one here plus to minus, now here minus to plus. So if I take this as positive, then I must take it as negative, that is why this is minus 40, and again it is positive negative, that is same as the voltage drop across the 5 ohm. So it will also be taken as positive. So from there I can easily find out Vx equal to VBC is equal to 40 minus 10 equal to 30 volt. Now I want to find out this Ix. This Ix is what? This Ix is, if I apply the KCL here, that is point A or node A, I can easily find out that 4 ampere of current is entering the node and 8 ampere of current is leaving the node, and the remaining amount of current will be the Ix. So I can find Ix equal to 4 minus 8 is equal to minus 4 ampere. That means this current is not leaving the node, it is entering the node. So as I have taken this Ix current is leaving the node, that is why here Ix is equal to minus of 4 ampere. The minus value is for the current direction is taken as negative. Okay. Next I just want to find out what is the value of IBC, that is current across here. What is the value of current? IBC is Ix plus 10. Okay. As I have taken the direction Ix like this, that is entering B, and 10 ampere is also entering B. So Ix plus 10 will be IBC. Then minus 4 plus 10 is equal to 6 ampere. That means IBC, direction of IBC is this only, as 6 ampere is positive. That means leaving the node B. Clear? Now from here I can find out what is R2. That is, this is R2, and this R2 is nothing but Vx by IBC. So Vx by IBC, that is 30 by 6 equal to 5 ohm. Now go to the AD point, that is here a AD. So AD point, now at AD point I can find out that what is the value of VAD. So VAD, again here is a KVL. So from this applying this KVL I can find out VAD is equal to 40 plus 6Ix, that is voltage drop across here, plus this, it will be equal to this. Okay, so 40 plus 6 into minus 4 is 16 volt. So from there I can find out R1, because VAD is known and I know the value of the current 8 ampere. So R1 is equal to VAD, voltage divided by current, it is 8 ampere, that is 16 by 8 is equal to 2 ohm. Okay, now the next question is find the voltage V. So here you can find that there is a circuit given, this is the circuit, and I want to find out the voltage V. I don't know what is the value of current I1, I don't know what is the value of current I2, but I just know what is the value of current I3. So find out here that 2 ohm and this 3 ohm both are in parallel. So when two resistances are connected in parallel, then the voltage across each the resistance will be same. So I can find out voltage across this 3 ohm easily, because current is known as well as the resistance is known. So voltage drop across 3 ohm is 3 into 1 volt is equal to 3 volt. Now I know that as 2 and 3 are connected in parallel, so voltage drop across 2 ohm will also be equal to 3 volt. So current across 2 ohm is voltage divided by resistance, resistance is 2, so current is 1.5 ampere. Now apply KCL at point A. Here you apply KCL at point A, and here you can find out that I1 amount of current is entering and I2 as well as I3 is leaving the node. So minus I1 plus I2 plus I3 is equal to 0. That is why I1 is equal to 1 plus 1.5 is equal to 2.5 ampere. Now apply KVL in this loop, that is in this first loop. Here you can find, I start from here, so minus to plus, that is I will take it as negative, that is source always taken as negative according to the IEEE convention. So minus V plus I1 into 4 by 9 ohm, that is I1 into 4 by 9 plus I2 into 2 ohm, so I2 into 2 is equal to 0. So V is equal to 2.5 into 4 by 9 plus 1.5 into 2, that is 1.11 plus 3 is equal to 4.11 volt. So voltage V, this V is equal to 4.11 volt. Now here is a question related to the equivalent resistance. So here you can find that the question is asked that find out the R equivalent. Seize the question and find out the R equivalent. So first of all, what to be noticed, that here it is asked what is the R equivalent, that is this point is connected across B, so you will have to find out the R equivalent from this point up to B point, and this 1 ohm is not connected, and so it is not contributing anything to the value of R equivalent. So here you can find A and B. Here 1 ohm resistances are connected in parallel, because this point and this point A and B. Here this point is nothing but this point, so connected across A and B. And here this point and this point, that is this point is nothing but A, so connected across A and B. 3 ohm are connected across A and B, So I can find out that 1 by RAB is equal to what? 1 by 1 plus 1 by 1 plus 1 by 1. So from there I can find out RAB equal to 1 by 3 ohm. Okay, now R equivalent is what? This is in series with this RAB, so R equivalent is equal to 1 plus RAB, that is 1 plus 1 by 3 is equal to 4 by 3 ohm. Okay, so never get confused when this type of question is given in the this type of circuit or this type of question is given in the examination, because you just have to focus on that where this R equivalent is to be calculated. So at first if you see, then you might think that this is going there and this is also a resistance here, but you don't have to bother with this resistance, because the rightmost, this 1 ohm does not have its one end connected. This is only one end connected. Second end is not connected in such a way that it is not contributing anything in R equivalent. So you will have to focus on this at first and then try to find out the value of R equivalent. This type of question are really easy, but depending upon the observation of the student, how he or she can observe the question, then he or she can easily find out the answer. So best of luck students, and please subscribe to my channel Kalyansis Sadhu, as this will help me to come live in the action in the upcoming sessions to clear the doubts related to the lectures I am delivering here, and hope for the best, hope for the good response, and I hope that you will must score good marks in the GLET. Okay, thank you all, and I am promising again that I will upload another video related to the logic gates, because I have seen that sometimes one or two questions are asked in the GLET relating to the logic gate concept. Okay, thank you all, best of luck.